Hi everyone, welcome to the video. We are going to solve city with the smallest number of neighbors at a threshold distance. Okay, the question name is long and explanation is longer than it. But I will tell you in easy language. See, we are given, first of all, we are given a 2D matrix, okay, along with n and m, okay, n and m. So we are given n cities, first of all, okay, we are given n cities. Cool. And what you have to do? See in the each edges what you can see is for every subarray you have three parts. So these three have a meaning. The first has source, second has destination, and third has the weight associated to reach from source to destination. Which means if you have to start, see in the graph also, if you have to start from 0 to 1, you will reach 3 weight. 0 to 1 3 weight, but there's a catch that this graph is bidirectional, which means if you can go from 0 to 1 using the weight 3, you can come back from 1 to 0 using the same weight but just 3. Similarly 1 to 2 using 1, 2 to 1 using 1 same. Similarly, okay, then again there's a value called threshold. So if you have to reach from city A, source A to destination B, cool, city A to city B, okay, since the nodes in this question are cities, nodes in this question are cities, so if you have to reach from A to B, node A to B, then you can obviously use intermediary nodes also, but that sum to reach from A to B should not be greater than this threshold value, which is 4 in example 1. Let's see in the graph, if it will start from 0 to 1 and then 2, you'll reach weight 4. Cool. If you have to start from 1 to 3, wait 4. Again, during the question also, if you have to start from 0 to 1 to 2, okay, you have to from 0 you can go to 1 and then 3, two cities. Okay, okay, see what I'm saying. We have to repeat the question also. Smallest number of neighbors at threshold distance. So the threshold distance should not get exceed, and the number of cities which you can reach should also be minimized. So from 0 you can reach two cities, and from 1 you can reach 0, obviously, then 2, obviously, and then 3 also. From 1 city 1 you can reach three places. But in the question we have to return the city with which you can reach the minimum number of cities. But from 1 you can reach three cities. From 0 you can reach two cities only. So in that case 1 is out of context. Let's move to another city. Okay, till now city 0 is good. City 2. From here you can go to city 1, city 0 again, and then city 3. See, you can go city 2 to 1, 1, then 2 to 0 using one intermediary city, 1 and 3. Weight is within the threshold limit. Okay, and then 2 to 3 again with the weight 1. You can go. Cool. Again, from city 2, you can go to three different cities, but we already have a city 0, with which you can go only two cities. In that case, city 2 is also out of context. It will not yield us question. So, till now, out of three cities, city 0 is at par. Now, come to city 3. See how many cities you can reach from here. You can reach city 3 to city 1, okay, with weight 1, with weight 4, sorry. Then again you can reach city 3 to city 2, okay, from 3 to 2 using weight 1. Again you have two weight only. That is good. That is good. That is good. Now we have two cities using which then only two adjoining cities can be moved. City 0 and city 3. But since city 3 has a greater number, I mean 3 is greater than the label value, the face value of 3 is greater than 0. In that case, you will choose 3. You will return 3 as a result. Okay. Similarly, in example 2, see out of all those nodes, you can reach, okay, threshold is 2 over here. Okay. From 0, you can reach to 1. From 1, you can reach 4 and then 0 again. Okay, and then from 2 you can reach 3 and 4, similarly so on and so forth. But from 0 you could have reached only one city, 0 to 1, using the threshold value. In that case you will return city 0, and no other city has less number of cities, adjoining cities. In that case this will be our answer. This will be our answer. Cool. So how will I do it? First of all, I tried to voucher algorithm for it, but that didn't yield any result. So now I will use Dijkstra's algorithm. So if you don't know what Dijkstra's is, I will just reiterate. So Dijkstra function we will implement, okay, to find the shortest distance from source S to destination D. Source S to destination D. It will take number of vertices, okay, the adjacency list, okay, and the source node as a input, as a input. It will take three input. What is the V? Adjacency list and source node as input, and will return the shortest distance from source node to distance node. How will I implement it? Let's go ahead. First of all, I'll need to import something, like from collections import default dictionary, and from EQ import push. Let's see. Let's go ahead. I will now use Dijkstra, AJKSTRA. What this is V again, what is this? No, what is this V? Then adjacency and then S. Okay. Now what is adjacency? First of all, let's build the adjacency in the main function. Okay. So adjacency will be default dictionary. The list which is given to us of type list, sorry, type list. Okay. Now for I in edges, let's build adjacency I to 0, I0, append I1, I2, means source and destination. Source and destination. Sorry, for I0. I0 is source, I1 is destination, and I2 is the weight. I2 is the weight. And then again, decency I1. And since these nodes are bidirectional, so if you can go from 0 to 1, then you can come from 1 to 0 but again. So in that case, node 1 is our source node, and node 0 will be our destination node. Really, weight will remain same. Weight we don't have to think about. Now that we have our adjacency list, let's build our Dijkstra's function. So first of all, our distance out. We have created our list with all infinity values, which is a distance for all the from traveling from source to destination. Now priority queue. Says initially distance will be 0 for a node. Now while there are elements in the priority queue, the distance node is equals to pop priority queue. Okay, will pop. So now you know what are the elements in this priority queue. First is the distance, and second is the node, source node. Cool. So since distance S was 0 in the beginning, now for all the elements in the adjacency will be two things: adjacency weight and adjacency node. Okay, in every adjacency. So what is that? First is adjacency weight, which is I1, and adjacency node, which is I0. Now we have to calculate the weight, the adjacency weight at the current distance. Adjacency weight plus current distance is less than the overall distance. The overall distance to travel to this adjacency node. To travel to this adjacency node, we have found a new replacement for this distance of adjacency node. I'm not explaining much on this Dijkstra's because this question is mainly to find this city, the main function, and Dijkstra I hope you people be aware of, since it is very generic algorithm. TQ distance and then the adjacency node, and then the adjacency node. At the end, we'll return the distance, return the distance. Cool. Now we'll come back to the main function and we'll implement it. Since we have already initialized and filled our adjacency list, now in that case, we'll see city count. Let's say city count is a very big number, very big number. And city number. City number is the one which we will return at the end. City number is the one we will return at the end. So initially it is -1, which means we have no answer. But as we progress ahead, we will calculate it. Now for C, for all city, we have in the range of n. For all the cities, C is a city. Okay. For all the cities, now we'll calculate the counter for every city. The counter for every city. Okay. The number of times it is being visited. The distance will be self dot extra spelling. Number of nodes was number of n, number of nodes here. Then adjacency is the same and the city is C. Okay, source is the city, this current city. Okay, the count is 0 in the beginning. For adjacent city, for all the adjacent city in this distance, if this adjacent city is less than or equal to distance threshold. Okay, we are given distance threshold, the maximum weight which we can spend to reach from city A to city B. We can use also the intermediate nodes. We know that. Okay. Now, if adjacencies, if this adjacency is less than or equal to the distance threshold, count will get increased by 1, which means this this can be used to reach to node B, city B from city A, from source to destination. We can use this. Okay. Now, now that we have calculated all the counters, now if this count is less than or equal to city count, now if this count is less than or equal to city count, okay, I will just move it onwards. Okay. If this count is less than or equal to city count, in that case, replace the city count with the calculated count, above calculated count, and the city number will be C. So in that case, in a loop wise, we'll traverse through all the cities, all the nodes. We'll calculate the number of cities which you can reach from that particular city, and at the end, the city with the minimum number of with the minimum number of adjacent cities will be our answer. And also, as you can see, we have in the example one, we had two possible probable answers, 0 and 3. But since 3 has a greater face value, in that case we return C. And in this case also, in our solution also, since we are progressing ahead using the loop, if there are cases with more than one case, when more than one cases have the same number of adjacent cities, but the city with the higher face value will come at the last and it will get appended. So in that case, we'll return the city number, which is the nth value, nth city with which you can get least number of adjacent cities. You are not crossing the. Okay, wait a minute. Okay, this is not adjacent city. It is. It should be weight, right? Yeah, it should be weight, not distance. I mean, it's not. You cannot add those two values. Yeah, as you can see, it does the job pretty effortlessly. I won't say pretty effortlessly. It is taking some time since although they have allowed us to use order of n cube, but when the flight washer was not working, I mean, because of Python being slow, being interpreted language. But at the end, you are able to learn and do the same question in much less time using a better algorithm, Dijkstra. I mean, I won't say Dijkstra is better, but at the end, you are able to learn new concept. I know. I hope you enjoyed it. So thank you. Have a nice day.